right, now let's look at finding the maximum value. And there's a few different ways you can do this depending on what information you're given, whether it's an equation or a graph or a table. If it's a graph, it's going to be the highest point on the graph. So that means if it's a trig graph, like the one that we see here below, the curve, that we're going to look for where the peak of the trig graph is. If it's a parabola, we're going to look for the y value of the vertex in a parabola that would be opening down. And if it's in a table, we're going to look for the largest y value in the table. So let's start by looking at f of x here. We're not given a graph for this first function, but we are given some information. We have a +3 at the end. And if you recall from our study of these transformations of trig graphs, the +3 at the end means that our midline is at 3. So that means 1, 2, 3. This is where our midline would be. And then the number out in front is the amplitude. That means how far above and below the midline our graph will go, which means we're not sure exactly where because we're not going to actually plot the whole thing, but we know that from this midline, our peak will be 2 units up and our valleys will be 2 units down. So if I'm looking for the maximum value, which is the highest point or the peak of the graph, if I start at 3 and I'm going to go 2 units up because that's my amplitude, then that would give me a maximum value of 5. All right, let's look at our graph. For the graph, it's a lot easier because I just look for the height of the peak. And here's my peak, and there's another peak over here. But they both have the same height, and that height is 5. So this also has a maximum value of 5. And then for the table, we're looking for the largest y value in the y column. So that looks like, in this case, it would be 0. Now sometimes you'll just see the number listed. Sometimes it will say y equals 5, or y equals 5, or y equals 0, because it's really the y value that we're looking for. The reason why you may not see it like this as often is because this is the graph, or if I were to graph y equals 5, it would be a horizontal line. And that's not what we're looking for at all. We're looking for that one maximum value of the function. So that's why usually you won't see it written like this. You'll see just the value. All right, and lastly, we can take the same types of displays of data and we can find the minimum. And the minimum y value will be the lowest point of the graph, the valley low of a trig graph, the y value of a vertex for a parabola, this time that's opening up, or the smallest y value in a table. So we're going to take this first one, and just like we did before, remember that this number is the midline. So that means that 1, 2, 3, 4, my midline would be right here. And then if my, let me fix that just a little. Got a little off track there with my dashes. So if the amplitude is 3, that means that I'm going to go 3 above my midline and 3 below my midline. So if my midline is at -4 and I'm looking for my minimum, that means from -4 I'm going to go 3 spaces lower. That's going to put me at -7. Right, then for the graph, like we saw before, it's easier when we have the graph. We just look for the lowest valley point, or the valley low, we could call it. And the valley low here is at -2. And then on the table, we look for the smallest y value. So last time we were looking for the maximum, this time we're looking for the minimum, so we're looking for the smallest value in this table, and it looks like it would be that value right there. So -4 would be our minimum for this table, for this function.